Thermodynamics is a fascinating field that deals with the transfer and transformation of energy. In the 19th century, scientists were building steam engines, combining heat and work to create incredible machines. The development of that field eventually resulted in 4 laws of thermodynamics, laws that can be used to explain why anything happens. The first law connects kinetic and potential energies to work done and heat, and is basically restating the law of conservation of energy. The second and third laws deal with entropy, an interesting variable that we will not look at all really. Basically, entropy is the order of a system, or disorder is a better way to look at it, I suppose. German scientist Rudolf Clausius's statement of the second law was simply that heat can never pass from a colder to a warmer body without some other change connected therewith occurring at the same time. In other words, the second law is that things cool down because heat always travels from hotter regions to cooler regions. The important part of the third law is that at absolute zero, energy is minimum. We'll come to that another time. With these laws, the scientists realized they'd forgotten to define temperature, which does seem quite important, so they added a 0th law. It's a tricky definition to understand through the English at first, though all it says is that if 2 systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. In essence, if T1 equals T3 and T2 equals T3, then T1 equals T2. This may seem obvious to you, but maths needs these things to be accepted as law in order to do more complex tasks with confidence. And that's thermodynamics. 0th law, temperatures of different things can be compared. First law, if you heat an object or do work on it, it gains internal energy. Second law, heat moves from hot regions to cool regions. Third law, at absolute zero, energy is minimum. It seems simple, but since these laws are used to explain why anything happens in the whole universe, including locomotion of a steam engine, there's clearly complexity in how to use them. In the next lesson video, we'll start with the first law of thermodynamics.